Some nights, just before a room goes fully dark, there is a strange kind of softness in the air, the kind of stillness that feels almost deliberate, as if the whole evening has quietly agreed to slow down. Somewhere past the window, the very last edge of sunlight might still be resting low against the horizon, taking its time before it finally lets go. If this feels like a good place to rest for a while, you are welcome to stay just as you are. Now let's drift slowly into something quiet, because right now, while the light is fading wherever you happen to be, that same sun is still rising for someone else somewhere on the far side of this turning world. It never really sets, it only moves. And there is something quietly comforting about that small, ordinary fact, the kind of detail that once noticed has a way of staying gently in the back of the mind. It seems like such a simple thing, a sunset. The sky softens, the colour drains slowly from the edges of the world, and then it is night. But almost nothing about that moment is as simple or as final as it appears. Astronomers have long pointed out that the sun never actually disappears at all. Earth is the one that moves. It turns slowly and steadily, carrying each part of its surface out of the light and into shadow, like a great wheel rolling forward through space, never stopping, never pausing to ask permission. Because of that turning, there is no single moment anywhere when the whole planet is dark at once. Right now, as this sentence settles into the room around you, somewhere a sky is brightening into morning. Somewhere else the very last warmth of afternoon is just beginning to cool. And somewhere a person much like you is also lying still, watching the same kind of fading light, perhaps even thinking the same soft half-formed thoughts about endings that aren't really endings at all. There is another quiet detail tucked inside all of this. Something researchers have calculated rather precisely. The light that reaches this exact moment, the light that coloured the sky only minutes ago, did not begin its journey now. It began its journey earlier. Sunlight takes about 8 minutes and 20 seconds to travel from the surface of the sun to wherever it eventually lands, whether that's an open field, a window pane, or the closed curtain of a bedroom at dusk. Which means that the sunset someone watched this evening was not really happening as they watched it. It had already happened several minutes earlier far away, and what arrived was simply its memory travelling quietly through the dark until it found somewhere to land. It may be that this is part of why sunsets feel the way they do, not urgent, not sudden. More like the tail end of something that has already passed, drifting in gently to say goodbye after the fact. There is a reason too for the particular colours that gather low in the sky during those final stretched out minutes. The soft golds, the muted pinks, the deep settling blues. Scientists have studied this for a long time, the way light bends and scatters as it pushes through more and more air near the horizon. Blue light tends to scatter, first spreading wide and disappearing into the upper sky, while the warmer tones, the ambers and reds, manage to travel further before they finally fade. It is a small kind of physics quietly playing out above every rooftop, every coastline, every quiet street each evening, without anyone needing to ask it to. Some scientists believe this scattering has shaped more than just scenery. Studies suggest that the slow shift in colour and light at dusk has, for as long as there have been eyes to notice it, given living things a kind of gentle signal that the day is folding closed. Not an alarm, not a warning, just a soft cue repeated every single evening, asking the world to begin settling down. And maybe that's part of why this particular kind of stillness feels so familiar. Long before clocks, long before any of the usual ways people measure an ending, there was only this, the sky changing colour, the air cooling slightly, the light pulling back toward the horizon a little at a time. It seems that something in the body still remembers that rhythm even now, even here in a room with the curtains drawn, and the rest of the world humming quietly somewhere outside. There is a particular comfort too in knowing that this sun, the very one tracing slow gold light across a windowsill tonight, is the same sun that warmed every quiet evening that ever came before this one. The same sun that touched fields long since paved over oceans that have shifted their shores many times and skies that no longer look quite the way they once did. It has been rising and setting in one place or another for a very long time, long enough that it almost feels less like an object out there in space, and more like something steady, something that has simply always been present, the way a familiar sound in another room can feel present even when nobody's paying close attention to it. Of course, steady is not quite the same as unchanging. Nothing, not even something as vast and dependable as a sun, stays exactly the same forever. But that's not something to think about too closely right now. Right now there is only this slow fading of light, this small daily disappearance that isn't really a disappearance at all, just a quiet handing off from one part of the world to another. So for now it might help to simply sit with what already feels familiar, the warmth that has always been there, low and constant, just beneath the surface of every ordinary day. Because before any of the deeper, quieter parts of this story can settle in, it helps to remember how steady this light has always felt, how long it has been doing exactly this, fading here, rising there, never quite leaving, only moving gently from one horizon to the next. Some of that same warmth you can still feel now settling into the room around you began its journey long before this evening existed at all. And maybe that's a good place to keep drifting from. The sun is in the simplest sense a star, not an exception to the rules that govern other stars, but one among an enormous family scattered across a galaxy that researchers estimate holds hundreds of billions of others very much like it. It does not stand apart from them in any dramatic way. It is simply close. Close enough that its light reaches this small, quiet planet in under 9 minutes, and close enough that almost everything alive here has learned slowly, generation after generation, to live by its rhythm without ever fully noticing. Scientists suggest the sun formed about 4.6 billion years ago out of a vast cold cloud of gas and dust drifting somewhere through space. Something disturbed that cloud, perhaps the shock wave of an older star nearby reaching the end of its own life, and the cloud began to collapse in on itself. Gravity pulled the material tighter and tighter until the very center grew so dense and so hot that something extraordinary happened. Hydrogen atoms crushed together under that pressure began fusing into helium, and in that fusion light was born for the first time. It seems strange in a way to think of something so calm as the result of so much pressure. But that is at its core what a star is. A quiet balance between two forces pulling in opposite directions, gravity trying to collapse everything inward, and the outward push of energy, released by fusion holding the whole structure gently in place. For 4.5 billion years that balance has held, without interruption, the kind of stillness that only comes from something working exactly as it was always going to work. What is easy to forget lying here in the dark is that the light reaching you tonight did not begin its journey today at all. Researchers have found that energy created at the very center of the sun does not travel outward quickly. It is born as an intense kind of radiation deep inside that fiery core, but it does not simply shoot straight out into open space. It gets absorbed and released and absorbed again, bouncing through the dense layers of the sun in something scientists sometimes describe almost gently as a random walk. That process alone can take over 100,000 years. Light born today will not reach the surface of the sun until long after everyone alive right now is gone. And then once it finally does reach the surface, the final stretch is almost startling by comparison. About 8 minutes. That is all it takes to cross the gap between the sun and the earth. So in a quiet, strange sort of way, the warmth on your skin earlier today was the end of an extraordinarily long and patient journey. One that began before recorded history understood much of anything at all, and ended only just now against the surface of your hand. There is something almost comforting in that, even if it is difficult to put into words. The sense that something has travelled a very long way just to reach you. If you could somehow look closely enough at the surface of the sun, it would not appear smooth or still at all. It would look in a strange way almost alive. Vast cells of glowing plasma, each one roughly the size of a country, rise up from below, cool slightly at the surface and sink back down again, only to be replaced by the next rising cell. This happens constantly all across the surface in a pattern astronomers call granulation. It resembles, oddly enough, the surface of a pot of water just before it begins to boil, except on a scale that is difficult to hold in the mind. Each of those cells lasts only about 20 minutes before dissolving and forming again. The sun, it turns out, is never truly still. It only seems still from this distance on an ordinary evening like this one. The mind quietly registers stillness in places where underneath none really exists. That tends to be true of almost everything in the night sky. What looks fixed and permanent up there is beneath the surface in constant motion, constant exchange, constant quiet change. The stars only appear unmoving because the distance between you and them is so vast that change becomes invisible, the way a tree at the edge of a field looks motionless from inside a moving car, simply because the car itself is so much closer. For most of human history, people had no real way of knowing any of this. They only knew the shape of the thing, a steady disk crossing the sky each day, rising and setting, with a patience that felt to them like a kind of promise. Entire calendars were shaped around its movement. Stone circles were built with quiet precision, just to mark the exact place it would rise on the longest and shortest days of the year. Different cultures gave it different names, told different stories about where it went at night, and yet underneath all of those different stories sat the very same star doing exactly what it had always done, indifferent to whatever meaning was placed upon it. Astronomers sometimes use a term for the sun that sounds almost affectionate given its size, a yellow dwarf. Not because it is small in any way easy to picture, but because among the wide range of stars that exist, it happens to sit comfortably in the middle. There are stars, far larger swollen giants, that could swallow the orbit of Mars without much difficulty, and there are stars, far smaller dim red embers that burn so slowly they could in theory last for trillions of years. The sun belongs to neither extreme. It is in almost every sense an average star living an unremarkable life in an ordinary arm of an ordinary galaxy. And somehow that is part of what makes it remarkable. Nothing about its size or position required it to support anything resembling life. It simply happened to be steady for long enough in the right place. That steadiness is not only about light either. The sun also releases a constant stream of charged particles flowing outward in every direction, what scientists call the solar wind. It moves past every planet, past the asteroid belt, past the orbit of Neptune, continuing on for billions of miles, before it finally slows and mingles with the thin material drifting quietly between the stars. This stream creates an enormous invisible bubble around the entire solar system, often called the heliosphere. In a sense, the reach of this one ordinary star extends far beyond the warmth it offers during the day. It shapes a soft, quiet border between the small world it built and the colder space that waits just beyond it. Some of that same solar wind brushing against the Earth's own magnetic field produces something far more visible, the slow drifting curtains of green and violet light seen sometimes near the poles. What looks from below like a kind of quiet magic is underneath a long and delicate exchange between particles thrown outward by the sun and the planet's own gentle defences meeting somewhere high above the clouds. There is one detail about the Sun that scientists are still exploring, something that does not fully add up even now. The surface of the Sun sits at a temperature of roughly 5,500 degrees, and yet the corona, the faint outer atmosphere that becomes visible only during an eclipse, somehow burns far hotter than the surface beneath it, sometimes reaching over 1,000,000 degrees. It seems almost backwards the way stepping farther from a fire should leave you cooler, not warmer. Studies indicate the answer may lie in the Sun's magnetic field, twisting and releasing energy in ways not yet fully understood. For now, it remains one of the quieter mysteries sitting in plain sight just past the edge of the light you can actually see. It may be that the Sun feels separate from daily life, something distant, something that simply happens in the background while the rest of life carries on beneath it. But almost everything alive on this planet still depends on it in ways that are easy to overlook. The rhythm of waking and sleeping, the way plants slowly turn themselves toward the light, the long unhurried turning of the seasons. None of it would exist quite the same way without that one steady star burning quietly, 4.5 billion years into a life that on the scale stars usually live by, has really only just reached its middle chapter. There is something gentle in that thought too. A middle chapter, not an ending, not even close to one. Just a long, calm stretch of a story that has been unfolding since long before anyone existed to notice it, and that will likely continue in roughly the same way for a very long time still to come. And yet even something as constant as that carries its own quiet arithmetic underneath the surface. A kind of slow counting that has been happening since the very beginning, hidden somewhere inside the same fire, that feels from here in this dark and unhurried room like it could simply go on forever. The slow counting that lives inside the Sun is not something visible from here. It happens deep beneath the surface in a place no telescope has ever truly seen, and it has been happening quietly every single second for 4.5 billion years without pause. At the very centre of the Sun, where pressure and heat reach levels difficult to picture, hydrogen is being converted into helium at a staggering pace. Scientists suggest something close to 600 million tons of hydrogen are fused there every second. Out of that, only a small fraction, just a few million tons, is released as pure energy, the kind that eventually finds its way to the surface and much later to the skin of a sleeping planet many millions of miles away. The rest becomes helium, a slightly heavier, quieter byproduct that does not rise back up. It simply settles, layer by layer, second by second, sinking gently toward the very center, like sediment gathering at the bottom of something vast and slow-moving. It seems strange to think of a star as something that accumulates anything at all. Fire in most of human experience consumes and disappears, leaving very little behind. But the Sun is not quite like an ordinary fire. What it leaves behind does not vanish. It stays pooling at the core, growing denser with each passing age, each passing era of geological time on the planet it quietly warms. Researchers have found that this slow accumulation of helium does something subtle to the Sun's own internal balance, the very same balance mentioned earlier between gravity pulling inward and energy pushing outward. As helium gathers at the center, that core becomes a little smaller, a little denser, a little hotter than it once was, and a hotter, denser core burns its remaining hydrogen just slightly faster than before. The Sun, in other words, has never actually been one fixed, unchanging thing. It has been very gradually brightening the entire time in ways far too slow for any human lifetime to notice. What we understand so far suggests the Sun today shines roughly 30% brighter than it did when the Earth was young. 30% across 4.5 billion years is an almost unimaginably gentle pace of change, so gentle that nothing alive ever needed to adapt quickly to it. And yet it raises a quiet question that scientists are still exploring even now. If the young sun was fainter than today's sun, how did early Earth sitting at the very same distance from it manage to stay warm enough for liquid water, and eventually for life to take hold at all? This puzzle has a name almost poetic in its own way, the faint young sun paradox. Evidence drawn from ancient rock formations suggests Earth's surface was not frozen solid during that early dimmer period, the way simple physics alone might predict. Something else was helping to hold in warmth. Some researchers point to a thicker blanket of greenhouse gases in that ancient atmosphere. Others suggest the planet's surface may have absorbed sunlight differently before oceans and continents settled into anything resembling their current shapes. It may be that several smaller factors work together quietly instead of one single explanation accounting for it all. The full picture even now is still being gently pieced together. There is something almost touching about the idea that a young, fainter sun and a young, unfamiliar Earth found their own quiet balance together long before either one resembled what they would eventually become. Two unfinished things somehow steadying each other in a partnership that took shape over hundreds of millions of years without either one being aware that it was happening at all. The brightening slow as it is never really stops. It continues now just as gently as it always has, and it will continue for a very long stretch of time still to come. The hydrogen at the sun's core, vast as it seemed earlier, is not unlimited. Nothing burning ever truly is. Studies indicate that roughly half of the hydrogen originally available at the very centre has already been spent across these 4.5 billion years. The remaining half is enough, scientists suggest, for the sun to continue on in very much its current form for around another 5 billion years. A number so large it almost stops meaning anything, the kind of number that the mind quietly registers, then gently lets go of the way it lets go of distances too vast to really hold on to. 5 billion years is longer than life on Earth has existed at all. Longer than the time separating now from the very first single-celled organisms drifting in ancient oceans. It is in almost every sense that matters to anyone lying here tonight simply not a concern. And yet it is also not nothing. It is a horizon, a soft, distant edge to a story that otherwise feels endless from any human vantage point. Psychologists often note that the mind tends to struggle in a fairly consistent way with timescales that stretch far beyond an individual lifetime. A year feels real. A decade feels real if a little hazy at the edges. A century already begins to blur into something more like an idea than a memory. By the time a number reaches the billions, something interesting happens. The feeling of scale tends to flatten out entirely. 1 billion years and 5 billion years can end up feeling emotionally almost identical, even though one is 5 times the other. The brain tends to interpret extremely large numbers more as a category, something like very, very far away, rather than as a precise countable amount. There is a kind of mercy in that in a way. It allows a number like 5 billion years to settle into the mind not as a countdown, not as something pressing or urgent, but simply as scale, as context, a reminder of just how much time the sun has already spent shining steadily over this small, quiet planet, and how much more of that same steady shining likely still lies ahead. None of this changes anything about the warmth in this room tonight, or the soft late hour settling in around you. The sun outside, wherever it currently sits along its own slow arc, around the other side of the world, continues exactly as it has continued for billions of years, already fusing hydrogen, gathering helium, brightening by amounts too small and too slow for any clock to register. It seems fitting somehow that something burning this steadily for this long should also be quietly, slowly counting the whole time without ever once interrupting the calm it offers everything living beneath it. And what that long patient counting eventually leads to far off, in the sun's own future, is something the body's own rhythms already seem to understand in their own quiet way, long before the mind ever puts it into words. There is somewhere in that quiet bodily understanding a kind of patience worth sitting with for a moment. The body does not rush toward endings. It simply allows things to happen slowly in their own time, the way breath deepens on its own once a room grows still enough. The sun, it turns out, carries that same kind of patience, woven into its own very long, very slow story. Around 5 billion years from now, scientists suggest the hydrogen fuel sitting at the very center of the sun will finally run out. Not all at once, not in any dramatic final moment. The core, after spending unimaginable spans of time converting hydrogen into helium, will simply reach a point where there is no longer enough hydrogen left there to sustain the same steady fusion that has held everything in balance for so long. And when that happens, something quiet but significant begins to shift deep beneath the surface in a place still untouched by any change visible from here. With less fusion happening at the very center, the outward pressure that has been holding the sun's enormous weight in balance grows just slightly weaker. Gravity, patient as ever, finally gets the upper hand it has been waiting for since the very beginning. The helium core, no longer producing its own energy, begins to contract under its own weight. It grows smaller, denser, hotter, the way anything tends to when there is nothing left to push back against the pressure surrounding it. What happens next is something researchers have found almost everywhere they look across countless stars similar to the sun. As that inert core contracts and heats a thin shell of hydrogen, still surrounding it, hydrogen that was never quite hot enough or dense enough to fuse before suddenly finds itself in conditions extreme enough to ignite. Fusion does not end there, it simply moves outward into a narrow shell wrapped around a core that has in a sense already finished its part of the story. It seems that this shift, modest as it sounds, changes almost everything about how a star behaves. A shell of fusion produces more energy more rapidly than the same fusion ever did when it was contained within the core itself. That extra energy pushes outward into the layers above it, and those outer layers respond by doing something almost the opposite of what the core just did. They expand. Slowly, gradually, but unmistakably, the sun begins to grow larger than it has ever been across its entire previous life. There is something quietly strange about a star growing larger, right at the point its core begins to fail. It is not unlike the way a flame just before it gutters out sometimes flares brighter for a moment, stretching wider before settling. Except here that stretching does not happen in a moment. It unfolds across hundreds of millions of years, far too slow for anything living to perceive as change at all. As the outer layers expand, they also cool. Studies indicate that a star's color shifts as its surface temperature drops, the same way a flame shifts from white toward orange as it loses heat. This sun, brilliant and yellow-white for billions of years, will slowly begin drifting toward a deeper, warmer orange, then eventually toward a soft, glowing red. Not because anything violent is happening to it, but simply because its surface spread now across a much greater distance has less heat to share across that wider span. This is the beginning of what astronomers call the red giant phase, though the word giant can be slightly misleading this early in the process. Evidence suggests the changes start subtly, the sun growing only a little brighter, a little redder over tens of millions of years at a time. A star, even in transformation, rarely seems to hurry. What we understand so far suggests this entire shift happens because of something almost touchingly simple. A star running low on what it once had in abundance, and quietly finding a new way to keep going anyway. The fusion does not stop. It relocates. The light does not disappear. It simply changes color, changes shape, continues on in a different form than before. There is something in that worth holding on to gently without needing to draw too firm a lesson from it. Endings, even stellar ones, often turn out to be less like a door closing and more like a long, slow turning towards something else entirely. While all of this unfolds far in the future, light is still making its own quiet journey tonight the way it always has. Some of the faint points overhead right now left their stars not years ago but centuries ago, sometimes much longer. The brain tends to interpret starlight as something happening in the present moment simply because it is arriving now, landing gently on the eye in this exact second. But what is actually being seen is something closer to a memory, a trace of light, carrying information about a star as it existed long before this night, long before this room, long before whoever is listening was ever born. Some of those distant stars, the very ones whose old light is settling quietly into the sky above right now, may have already begun their own version of what the sun will eventually experience. Their cores may already be contracting, their outer layers may already be swelling, cooling, reddening in real time somewhere far away, and there would be no way of knowing it from here. Not yet. Not for centuries more in some cases, until that newer light finally completes its own long crossing through the dark. In a quiet way, looking up at night means looking into something like memory itself. Old light carrying old information about places and processes that have likely already moved on without it. The sky does not show what is happening right now. It shows what was true once a very long time ago, faithfully delivered across a distance too vast to rush. Psychologists often note that memory works in a strangely similar way, holding on to a version of something that may no longer match what is true in the present moment. A memory of a place, a person, a feeling carried forward faithfully across years, even as the original thing it represents has quietly continued changing somewhere else, unaware that an old version of itself is still being carried so carefully by someone somewhere. The sun for now has not yet reached that turning point. Its core still burns hydrogen steadily, the same way it has for 4.5 billion years already. The shift described here remains comfortably distant, still resting somewhere on the far side of an almost incomprehensible stretch of time. Tonight's light, the warmth still lingering faintly in the walls of this room, left a star still very much in the calm, settled middle of its life. But it may be that distant stars overhead, the quiet glowing points scattered across the dark right now, are already further along in this very same process than the sun has even begun. Already reddening, already swelling somewhere out there in the kind of slow transformation that takes far longer to notice than a single human lifetime allows. And what becomes of a star once it finally leans fully into that long, slow widening turns out to involve some of the very same neighbors that have shared its sky for billions of quiet years. You said ban la chuyen giaviet kich bantiengan ke chuyen, kwa hok truos king utren ken YouTube bancho mosak ke chuyen jog jao hup, then rieng beat mang jam derm. Those neighbors are the planets small and steady, each one quietly orbiting the same gentle source of warmth and light for billions of years, now never quite touched by the slow transformation, building somewhere deep inside their shared star. Mercury sits closest, a scorched, airless little world that has spent its entire existence circling tightly around the sun, closer than anything else in this solar system. Scientists suggest that once the sun begins to swell into its red giant phase, expanding far beyond its current size, Mercury will not be able to remain where it is. The sun's outer surface, stretching outward over hundreds of millions of years, will likely reach the orbit Mercury currently occupies and quietly absorb it. Not violently, not in any single dramatic instant. more like a slow tide rising to meet something that was always going to be swallowed eventually. Venus, the next planet out, faces a future that researchers describe with a bit more uncertainty. Some models suggest its orbit too falls well within the Sun's eventual reach. Others propose something gentler, that as the Sun expands, it also loses a meaningful portion of its own mass blown outward as stellar wind. Less mass means a weaker gravitational pull, and a weaker pull means the remaining planets could drift slightly outward over time, the way a spinning dancer slows and widens their arms as the momentum eases. It seems that Venus's fate depends on a delicate balance between how quickly the Sun expands and how quickly its gravity loosens its grip. Studies indicate the outcome could go either way. And then there is Earth. For a long time, the assumption was simple that Earth too would eventually be consumed just as Mercury almost certainly will be. But it may be that the truth is a little more nuanced than that. As the Sun sheds mass during this later stage of its life, Earth's orbit, like Venus's, could gradually widen outward, putting some additional distance between itself and the slowly swelling star. Some research has suggested this widening might be just enough to let Earth narrowly escape being physically engulfed, and yet evidence suggests engulfment is only part of the danger. Even if Earth's orbit shifts outward, the Sun's enormous outer atmosphere, thin as it becomes at its very edges, may still extend far enough to create drag, a kind of gentle resistance, pulling against Earth's motion, slowly stealing its orbital energy over time. That drag, some studies indicate, could be enough to pull Earth back inward again, even after drifting safely away. There is something quietly poetic in that possibility, a planet given a temporary reprieve only to be drawn back slowly and patiently into the very star it once seemed to be escaping. None of this happens quickly, and none of this happens soon. The timeline involved stretches across hundreds of millions of years, layered on top of the 5 billion years still remaining before any of it even begins. It is less a forecast to worry over, and more a kind of distant outline sketched faintly at the very edge of an unimaginably long story. What we understand so far suggests Earth's fate may not be decided by any single dramatic moment at all, but by an accumulation of small quiet shifts. A little less mass here, a little wider orbit there, a little drag pulling gently against that wider orbit over and over across spans of time too long for anything alive to track. The kind of ending, if it can even be called that unfolds more like a tide slowly reclaiming a shoreline than like anything sudden or sharp. There is in a strange way something worth sitting with in the fact that scientists can trace this story forward at all, using nothing but light mathematics and patient observation of stars that are not the Sun, but are doing right now in real time exactly what the Sun will eventually do. Look up on a clear night, and somewhere near the shoulder of the constellation known as Orion sits a star called Betelgeuse, glowing with a deep, unmistakable reddish-orange. Betelgeuse is already a red giant, though a much larger and more massive one than the Sun will ever become. Its outer layers have already swollen to an almost unbelievable size, large enough that if placed at the centre of this solar system, it would likely stretch out past the orbit of Jupiter. Astronomers studying Betelgeuse are in effect studying a preview star further along, in a process the Sun has not yet begun. Not far from there, in the constellation Bootes, sits Arcturus, another red giant, smaller and gentler than Betelgeuse, closer in spirit to what the Sun itself may eventually resemble. Arcturus shines with a warm orange glow, easily visible without any equipment at all, simply by knowing where to look. Researchers studying its surface, its slowly shifting brightness, its quiet rhythms of expansion and contraction, are essentially watching a kind of future written out in real time on a star that already crossed the threshold the Sun is still slowly approaching. The mind quietly registers these stars as fixed points, the same comforting shapes traced into constellations going back thousands of years. But each one carries its own private story of change happening just slowly enough to remain invisible from here. Aldebaran glowing reddish in the constellation. Taurus is another red giant one with at least one known planet still orbiting it, according to evidence gathered through careful patient observation of the small rhythmic dimming caused as that planet passes in front of its star. A whole planetary system continuing on even after its star has already crossed into the very stage the Sun will eventually enter. It seems that nothing about this process is unique to the Sun at all. It is simply what stars of this size do given enough time. The Sun's future is not some isolated, unprecedented tragedy waiting to happen. It is closer to a well-worn path, one that countless stars across the galaxy have already walked, are walking right now, or are still patiently waiting their turn to begin. Psychologists often note that unfamiliar changes feel heavier, more uncertain when they seem to be happening for the first time to someone facing them entirely alone. But change that has already happened somewhere else to something else tends to settle differently in the mind. Quieter. Less like an unknown, and more like a pattern simply waiting its turn. The Sun, in this sense, is not facing anything unprecedented. It is following the same long, unhurried path so many other stars overhead have already followed, are currently following, or will follow long after this particular night has passed. Betelgeuse, Arcturus, Aldebaran. Each one a quiet kind of evidence scattered gently across the sky that this entire process, slow and strange as it sounds, is simply how stars like this one are built to age. And as that long, slow widening continues far closer to home, something else begins shifting too. Something that has less to do with planets being swallowed, and more to do with the soft, gradual warming of a world that has not yet been touched at all. Touched, but not unaffected. Long before the Sun ever begins to visibly swell into anything resembling a red giant, something quieter and slower has already been unfolding on Earth itself, set in motion by the very same gradual brightening, described earlier, that almost imperceptible 30% increase already accumulated since the planet was young. Scientists suggest that increase in brightness does not pause once it reaches the present day. It simply continues at roughly the same gentle pace as before, climbing by a small fraction of a percent every 100 million years or so. A rate so slow that no single human lifetime or even hundreds of lifetimes strung together could ever notice it directly. And yet stretched out across enough time, even the gentlest of changes eventually crosses a threshold. Researchers have found that somewhere between 500 million and 1.5 billion years from now, long before the Sun's core ever runs short on hydrogen, this slow brightening alone may be enough to begin reshaping Earth's climate in ways far more permanent than anything the planet has experienced before. Not through any sudden event, through accumulation, the same kind of patient, quiet build-up that shaped the Sun's own internal arithmetic, mirrored now in the temperature of oceans and the chemistry of an atmosphere. As sunlight grows marginally stronger, more water evaporates from the oceans. That additional water vapor evidence suggests behaves as a particularly effective greenhouse gas, trapping additional heat near the surface, which in turn encourages even more evaporation. A loop gentle at first, almost unnoticeable, but one that does not naturally correct itself once it begins to build. Climate scientists sometimes refer to the most extreme version of this as a runaway greenhouse process, though it may be worth setting aside the word runaway for a moment. What it actually describes is something closer to a long, slow, tipping spread across tens of millions of years each year, only fractionally warmer than the one before it. It seems that oceans, vast as they are, do not simply disappear in some dramatic instant. Studies indicate they recede, gradually evaporating a little more than they replenish, year after year, century after century, until what was once a blue and abundant world slowly becomes something drier, quieter, and considerably less hospitable to the kind of life it once supported so easily. There is something almost difficult to hold in the mind about the idea of oceans that have existed for billions of years slowly thinning the way. Morning mist eventually lifts and disperses once the sun climbs high enough. Not violently taken away, simply gradually return to the sky. Long before any of that unfolds, though, something far closer and far gentler continues quietly shaping life on Earth. Something that has nothing to do with billion-year timelines, and everything to do with this very night, this very room, this very body settling slowly into rest. Neuroscientists have observed that the human body holds an internal clock, a small cluster of cells near the base of the brain known as the suprachiasmatic nucleus that tracks the rising and setting of the sun with remarkable precision, even without any conscious awareness that it is doing so. Light entering the eyes, particularly the soft blue wavelengths most common in daylight signals, to that cluster of cells that the time for wakefulness has arrived. As that light fades as evening settles in the way it has tonight, the signal quiets, and the body begins almost on its own, preparing itself for rest. It may be that very little about this process feels conscious or deliberate. The mind does not announce the shift. It simply happens quietly the way a room grows dim as clouds pass overhead without anyone needing to flip a switch. Melatonin, a hormone produced by a small structure deep within the brain called the pineal gland, begins to rise as darkness falls, encouraging a gentle drop in core body temperature, a softening of alertness, a slow drift toward the kind of stillness that makes sleep possible at all. What is easy to overlook lying here now is how directly this entire internal rhythm still answers to the sun, the very same star whose long, slow story has been unfolding across this telling. Long after agriculture, long after electric light, long after clocks and calendars and every other human invention, meant to measure time independently, the body has continued keeping its own far older kind of time set, not by any device, but by the rising and setting of that one steady, ordinary star. The brain tends to interpret darkness itself as a kind of instruction, even now, even in rooms lit only by the faint glow of a screen or a streetlight slipping through a curtain. Something in the body still remembers an older world one, without artificial light at all, where darkness meant only one thing, and the body responded to it the same way faithfully for far longer than recorded history has existed to document. There is a kind of quiet trust in that worth noticing without needing to examine too closely. A body shaped slowly over hundreds of thousands of years to soften and rest, in response to the very same star now living through its own slow, unhurried middle age somewhere on the other side of the world. Skin too carries its own quiet relationship with sunlight, one separate entirely from sight. Thermoreceptors scattered across its surface respond to warmth, directly registering the gentle radiant heat of sunlight, even with eyes closed, even in sleep. Researchers studying touch and temperature perception have found that warmth itself, independent of any visual cue, tends to produce a measurable sense of calm, a slight easing of muscle tension, a softening that the body seems to recognize before the mind has any chance to name it. It seems that warmth has always meant something slightly different to the body than light does. Light tends to signal wakefulness, alertness, the beginning of motion. Warmth, especially gentle, steady warmth, tends to signal something closer to safety. The kind of warmth that comes from sunlight on skin or from blankets gathered close on a quiet night communicates in its own wordless way that nothing urgent needs to happen right now. that it is in fact a reasonably good time to rest. What we understand so far suggests this response may be older than conscious thought, itself woven into the body long before language existed to describe it. A kind of inherited memory not stored in any single thought or recollection, but carried instead in the steady automatic responses of the nervous system itself responding to warmth, exactly the way countless generations before responded to it, stretching back further than anyone could reasonably trace. There is a quieter layer to this one that most people never really stop to consider. The same star whose slow brightening will hundreds of millions of years from now gradually warm Earth's oceans into mist, is also tonight the very source of warmth, still gently held in the walls of this room, lingering quietly from a day already past. The same force operating across two entirely different timescales, one stretching for hundreds of millions of years, the other settling softly into a single evening. And what waits quietly within that same source of warmth once its long, slow story moves further along is something that does not disappear so much as transform, scattering itself outward in a way that scientists are still only beginning to fully describe. The transformation rarely happens all at once. It tends to happen in stages, each one quieter than the last, the way an evening doesn't simply end, but eases itself gradually into night. Once the sun's outer layers have expanded into the soft swollen shape of a red giant, its helium core continues contracting and heating, even as a wide hydrogen shell fuses steadily around it. Scientists suggest that eventually, after enough contraction, the core itself reaches a temperature high enough to begin fusing helium directly in a sudden but quiet event astronomers call the helium flash. It sounds dramatic by name alone, yet it occurs deep inside the star, entirely hidden from view, releasing an enormous burst of energy that the outer layers simply absorb without any visible change reaching the surface. A profound shift happening invisibly, the way some of the most significant changes in a life often do somewhere beneath the surface long before anything outward ever shows it. After that helium ignition settles into a steadier rhythm, the sun enters a more stable, though still temporary stretch of its life, fusing helium into carbon and oxygen at its core. This stage tends to last a relatively shorter while compared to the hydrogen-burning years that came before it, perhaps only a few 100 million years rather than billions. Researchers have found that stars in this phase often shrink back somewhat from their earlier red giant size, settling into a calmer, more modest glow for a time, almost as if catching their breath before the final stretch of the story begins. That calm, though, does not last. Once the core's helium also runs low, the same pattern that unfolded earlier repeats itself almost like an echo. The core contracts again. A new shell, this time burning helium, ignites around it, layered just outside an even older shell, still fusing hydrogen further out. The Sun, by this point, becomes something astronomers describe as an asymptotic giant branch star. A structure built almost like the rings of a tree, each layer marking a different stage of fusion stacked one upon another around a center that no longer produces the energy it once did. It seems that in this stage the Sun grows even larger than before, swelling further outward, its outer layers loosely held by gravity, that has grown comparatively weaker as the star's structure has changed. Studies indicate the surface becomes unstable in a particular rhythmic way, pulsing gently in and out over periods of months or years, brightening and dimming in long, slow cycles, almost like breath drawn unevenly in and out, in and out. These pulses, scientists believe, gradually loosen the Sun's grip on its own outer material. With each pulsation, a little more of the star's outermost layers drifts outward into space, carried on a slow, stellar wind far stronger than the gentle one the Sun produces today. Evidence suggests this process can repeat many times each pulse, releasing a little more material until the star has shed a significant portion of its original mass layer by layer, breath by breath into the surrounding dark. There is something quietly moving in that image, a star slowly exhaling itself outward, not violently, not all at once, but gradually, the way a held breath eventually has to release, slowly, almost reluctantly, until there's nothing left to hold. Eventually, what remains of the outer envelope becomes thin enough, loose enough, that it simply drifts away, entirely expanding outward into space as a vast, slowly dispersing shell of gas and dust. What we understand so far suggests this final shedding can happen relatively quickly in stellar terms, perhaps over just tens of thousands of years a moment by the Sun's own 4.5 billion year standard, almost like the final soft exhale at the end of a very long breath. What's left behind at the very centre of all that drifting material is the Sun's old core, now exposed directly to space for the first time in its entire existence. Still extremely hot, tens of thousands of degrees at its surface, this exposed core radiates intense ultraviolet light outward into the very shell of gas the star has just released. And that radiation does something remarkable to the surrounding material. It excites the atoms within that drifting shell, causing them to glow on their own in soft, distinct colours, the way certain gases glow when subjected to an electric current. Astronomers call the resulting structure a planetary nebula, though the name itself is something of a historical accident given to these objects centuries ago, because early telescopes made them appear faintly like the soft, round disks of planets. They are not planets at all. They are the slowly expanding remains of a star very much like the Sun, glowing gently from within, lit by the very core it once surrounded. Some of these structures studies indicate take on extraordinarily delicate, intricate shapes. The Ring Nebula. Drifting quietly within the constellation, Lyra appears through a telescope as a soft, glowing loop, almost like a smoke ring suspended in the dark. The Helix Nebula, somewhat closer to Earth, spreads out in long, layered filaments that some have likened gently to a vast, half-closed eye, watching nothing in particular, simply glowing softly at the centre of the slow disintegration that created it. The Cat's Eye Nebula reveals in detailed images a series of nested looping shells, evidence researchers suggest of multiple separate pulses of mass loss, each one layered carefully outside the one before it, like the rings hidden inside a tree, only here drifting freely outward instead of staying fixed in place. It may be that no two of these nebulae ever look quite the same, even though they all begin from a strikingly similar process. Slight differences in a star's rotation in companion objects nearby, in the precise rhythm of its final pulses, shape each resulting nebula into something unrepeatable, a kind of fingerprint left behind by a star's own particular way of letting go. The Sun, when its own time eventually comes, is expected to form a planetary nebula of its own, glowing softly, for perhaps 10 or 20,000 years before fading. Not a long span by the standards already discussed throughout this story, but vastly longer than anything resembling a single human moment. Long enough for that soft glowing shell to drift outward across a significant portion of space, slowly mixing with the thin, quiet material already scattered between neighbouring stars. That material does not simply vanish once the glow eventually fades. The mind quietly registers an ending in language like this, a star releasing its outer layers, but what actually happens is closer to a kind of return. The same hydrogen, helium, carbon and oxygen that once made up the Sun's outer atmosphere becomes instead part of the broader interstellar medium, the very same kind of diffuse drifting material from which the Sun itself originally formed all those billions of years ago. There is something gently circular in that. The cloud that gave rise to the sun was built from material released by older stars long before the sun ever existed at all. And one day the sun's own released material will drift outward in much the same way, settling quietly into the vast slow currents of gas and dust that move continuously through this region of the galaxy. Not lost, simply returned the way water returns gently to the sea, indistinguishable afterward from everything else it joins. Psychologists often note that letting go in almost any context tends to feel more like erasure in the moment than it actually turns out to be in hindsight. What disperses rarely disappears entirely. It tends instead to become part of something larger, harder to trace precisely but not truly gone. The shape changes. The substance in some quiet sense continues. For now, though, the sun remains exactly as it is tonight, comfortably distant from any of this, its hydrogen still burning steadily at the core, its light still taking that same 8-minute journey it has taken for billions of years already. The pulsing, the shedding, the soft expanding rings of glowing gas, all of it belongs to a future so distant it barely qualifies as a concern, more a quiet shape on a very long horizon than anything pressing. And yet tucked somewhere inside that slow unravelling of light and gas, right at the very centre of where a planetary nebula eventually fades, something else continues on quietly, long after the glow around it has dimmed completely into the dark. You said, Banla chuyen gia viet kichpan tieng anke chuyen hoa hok trus king utrenken YouTube. Ban kom os sak chuyen jog jau haptan rieng beat mang jammed. What continues on quietly at the very centre of all that drifting glow is something almost startling in how small it has become compared to everything it once was. Once the sun has shed its outer layers, entirely releasing them outward into the soft expanding shell of a planetary nebula, what remains is the star's original core. The same dense knot of material that spent billions of years quietly accumulating beneath the surface. Scientists suggest this remnant, called a white dwarf, packs roughly the mass of the entire sun into a sphere no larger than Earth. Not larger than the sun used to be, not even close. Roughly the size of this one ordinary planet, holding within it almost the full weight of the star that once stretched far enough to nearly swallow it. It seems almost impossible to picture at first something that dense. A single teaspoon of white dwarf material, researchers have found, would weigh somewhere in the range of several tons here on Earth, roughly the weight of a small car compressed into a space barely large enough to stir into a cup of tea. The matter itself has been crushed so tightly that atoms no longer hold their usual comfortable distance from one another. Electrons, the tiny particles that once orbited loosely around atomic nuclei, are pressed instead into a tightly packed shared space, resisting any further compression through a quiet, strange quantum mechanical rule, something physicists call electron degeneracy pressure. It may be that the easiest way to hold this idea gently in mind is to think of it less as something burning, and more as something simply stubbornly refusing to collapse any further. There is no fusion happening anymore inside a white dwarf. No fire in the way fire has been described throughout this story so far. Just an immense silent pressure holding a once active star together through nothing more than the quiet insistence of its own particles, unwilling to be pushed any closer. Studies indicate the core left behind by a star like the Sun is made primarily of carbon and oxygen, the very same elements quietly produced earlier during that helium-burning stage that briefly followed the red giant phase. In a sense, the white dwarf is something like a kind of ash, though even that word doesn't quite capture it. Ash, after a fire, tends to scatter, lose its shape, drift apart easily. A white dwarf does the opposite. It holds together tightly, becoming denser and more compact than almost anything else that forms naturally in the universe. aside from a small handful of even stranger objects. What we understand so far suggests this remnant carries a temperature at least initially far higher than anything experienced on the Sun's surface today. A newly formed white dwarf can burn at well over 100,000 degrees, glowing a brilliant blue-white, though by this point there is no atmosphere left to warm, no planets close enough to feel that heat in any meaningful way. The light radiates outward into open space, illuminating little more than the faint dispersing remains of the nebula that once surrounded it, slowly fading as the gas drifts further and further away. This is not a hypothetical outcome drawn only from theory or distant calculation. Astronomers have already observed white dwarfs scattered throughout the galaxy, some of them quite close relatively speaking to our own solar system. One of the most familiar sights besides Sirius, the brightest star visible in the night sky. What looks to the unaided eye like a single brilliant point of light is actually two stars orbiting one another. Sirius itself, a bright ordinary star, and a faint companion known as Sirius B, a white dwarf roughly the size of Earth, quietly circling its much larger neighbour every 50 years or so. Evidence suggests Sirius B was once a star considerably more massive than the Sun, one that lived its entire life far more quickly, exhausting its fuel and collapsing into this dense, quiet ember long before Sirius itself has even begun to age in any noticeable way. There is something quietly humbling in that faint companion barely visible without a telescope that has already lived through the very transformation the Sun has not yet even begun. What happens to a white dwarf after this point is in some sense the simplest part of the entire story and also the longest. With no fusion left to generate new energy, a white dwarf has nothing more to do than slowly, gradually cool. The light it emits comes only from the heat already stored within it, radiating outward second by second, century by century, the same way a dying ember continues to glow faintly, long after a fire has gone out, simply releasing the warmth it has left with nothing left to replenish it. Researchers have found that this cooling happens unevenly faster at first, while the white dwarf is still extremely hot, then more and more slowly as its temperature drops. The earlier stages of cooling, those first few 100 million years, see the most dramatic loss of heat and brightness. After that, the pace eases considerably the way a cup of tea cools quickly at first, then lingers at a gentle warmth for a surprisingly long while before finally settling to room temperature. What is easy to overlook sitting here in the quiet of tonight is that this is not simply some distant abstraction. There are white dwarfs known to astronomers that have been cooling for billions of years already, some among the oldest objects in the entire galaxy, quietly drifting through space, growing dimmer and dimmer, while everything else around them continues to change. One particular detail, something scientists are still exploring even now, involves what happens deep within a white dwarf as it continues cooling over these immense stretches of time. As the temperature drops low enough, the carbon and oxygen inside the white dwarf's core, no longer agitated by the same intense heat that once kept everything in a fluid shifting state, may begin to arrange themselves into an ordered crystalline structure. In simpler terms, the core itself may slowly turn, at least in part, into something resembling an enormous dense crystal. Astronomers studying one particular white dwarf, catalogued simply as BPM 37093, found evidence consistent with significant crystallization already underway within its core given its mass, its age, and the particular way its light dimmed and brightened in patterns linked to its internal structure. Because the dominant material involved is carbon, some researchers have half playfully described the result as something close to an enormous diamond floating quietly in space, far larger than anything that could ever be held or seen directly or known by anyone standing beneath it. It seems fitting somehow that something which spent billions of years as a brilliant restless fire would end its active life by slowly settling into something so still, so ordered, so quiet. Not extinguished, not erased, simply rearranged on the inside into the most stable, most settled form its remaining material can take. There is a kind of quiet stillness in that worth noticing beyond the science of it. Psychologists often note that as life slows in late evening, in deep rest, the mind tends to move away from anything resembling sharp active thought and towards something calmer, more settled, less defined at the edges. Something not unlike the slow ordering that happens on a much vaster scale inside a star's final ember, as motion eases and structure quietly settles into place. The white dwarf that the sun will eventually become carries within it, in a sense, the entire history of everything that came before. The hydrogen it once burned for billions of years, the helium it later fused briefly into heavier elements, the carbon and oxygen produced in that process now locked together, slowly cooling, slowly, crystallizing inside a sphere not much larger than the very planet currently holding whoever happens to be listening to this tonight in the quiet dark. It will not glow as brightly as the sun does now. It will not warm any nearby world the way today's sunlight still lingers faintly in these walls. But it will not disappear either. Not quickly. Not for a very, very long while yet. What we understand so far suggests this slow ember, once it fully forms, will continue cooling for an almost unreasonable length of time, far longer than anything discussed so far in this story. Longer even than the age of the universe as it currently stands. The mind, it seems, has been keeping something still and patient all along, somewhere in its own quiet corners, in the same way this small dense remnant will keep something quiet and patient at the centre of an empty, darkening corner of space. And just how long that patience might actually stretch, scientists are still only beginning to fully imagine. The patience held by a cooling white dwarf is not the kind of patience easily measured against anything familiar. It exists on a timescale that makes even the 5 billion years already mentioned in this story feel almost immediate by comparison. Scientists suggest that once the sun has fully become a white dwarf, its slow fade will continue for an extraordinarily long while before reaching anything resembling true darkness. The earlier stretch of cooling, several 100 million years, sees it dim from a brilliant blue-white down to something closer to the warm yellow-white familiar from tonight's daylight, then gradually further into a deeper orange, then red, the colours slowly retracing in reverse, much of the same progression a star moves through earlier in its life, except now drained of any new energy to sustain it. After that, researchers have found the pace of fading slows considerably. A white dwarf several billion years old glows only faintly, a dim red ember difficult to detect even with sensitive instruments, unless it happens to be relatively close, and the process does not stop there. It simply continues more and more gradually, cooling further still toward red, then toward a colour fainter than red, eventually radiating mostly in wavelengths the human eye was never built to perceive at all. It seems that somewhere far beyond this point, trillions of years from now, a white dwarf would theoretically finish cooling, entirely fading, until it no longer emits any meaningful light or heat at all. Astronomers have given a name to this final fully cooled state, even though none are thought to exist yet anywhere in the universe. They call it a black dwarf. Not because anyone has ever observed one, but because the mathematics describing how white dwarfs cool extended far enough into the future points quietly toward this as their eventual inevitable destination. What we understand so far suggests the universe at roughly 13.5 billion years old simply has not existed long enough yet for any white dwarf to have finished cooling all the way down. Even the very oldest white dwarfs, known ones that formed when the universe itself was still young, remain detectably warm today, faint but not extinguished. A black dwarf, by current calculations, would take somewhere on the order of a quadrillion years or more to fully form a span of time so far beyond ordinary comprehension that the universe's entire history up to this point amounts to barely a passing moment by comparison. There is something quietly strange about a destination that has never once been reached anywhere by anything in the entire universe so far. Not because it is impossible, simply because nothing has had enough time yet. Every white dwarf currently drifting through the galaxy, everyone ever observed by anyone, is still in some sense unfinished, still cooling, still technically in the middle of something that will not conclude for an almost incomprehensible stretch of time still to come. Evidence suggests that even after a white dwarf theoretically reaches this fully cooled dark state, its story may not be entirely finished. Some physicists exploring the very outer edges of theoretical understanding have proposed that protons themselves, the tiny particles that form the building blocks of all matter, might not be perfectly stable across timescales vast enough. If protons do eventually decay, an idea that remains unconfirmed and may never be confirmed within any observable time frame, even a fully formed black dwarf might slowly, almost imperceptibly, continue to change matter, quietly converting into energy across a span of time so enormous that the word billion stops being a useful unit of measurement at all. It may be that thinking carefully about timescales like this eventually stops feeling like thinking about the future and starts feeling like something closer to staring into a kind of depth, the way looking down into very dark, very still water can produce a quiet, specific kind of vertigo, not from danger, but simply from not being able to locate a bottom. Psychologists often note that the human mind did not evolve to process timescales anywhere close to this. Evolution shaped perception around the length of a single life, a single season, a single day's worth of light and dark. A quadrillion years carries no emotional weight, the way tomorrow does, the way next week does, the way even 10 years from now still carries some faint traceable shape. Numbers this large tend to pass through the mind without leaving much of an impression, at all the way water passes through an open hand, present for a moment, then simply gone without ever really being held. And yet there is something almost gentle in that limitation rather than something frustrating. It may be that the mind, unable to hold timescales this vast in any meaningful way, simply sets them down instead, the way a heavy object too large to carry far is eventually sensibly left behind. What remains after letting a number like a quadrillion years pass quietly through awareness, without trying to fully grasp it, is something softer, a sense of scale, a sense of how very small any single concern, any single evening, any single life actually is set against the kind of time the universe seems to have available to it. That smallness does not need to feel frightening. Researchers studying the psychological effects of contemplating vast scale, sometimes called the overview effect, when experienced by astronauts looking back at Earth from space, have found that this kind of perspective tends to produce something closer to calm than distress. A quiet, settled feeling often described less as fear and more as a kind of relief. The sense that very little needs to be carried so tightly, so urgently, when held up against something this large. It seems that awe, studied carefully by psychologists over the past few decades, tends to work this way fairly consistently. Standing beneath something vast, whether a night sky full of stars, an old and towering forest, or simply the quiet weight of deep time itself, tends to shrink the sense of personal urgency, while expanding gently a sense of connection to something larger and steadier than any single worry could ever be. Studies indicate this effect is measurable, a softening of stress response, a slight slowing of breath and easing that many people describe afterward as feeling smaller and calmer at exactly the same time. There is something in that worth letting settle quietly here in this dark, unhurried room. The same vast stretch of time that will eventually carry the sun's ember toward a fade so complete it borders on theoretical is also somehow a source of ease rather than alarm. Not because the scale is comforting in any small or personal way, but because there is a kind of relief in realizing how little needs to be solved or finished or worried over tonight against a backdrop this enormous. The white dwarf the sun eventually becomes will likely never witness another sunrise the way Earth understands one, never warm another ocean, never cast another shadow across a field at dusk, and yet it will not be without purpose even in its long quiet fade. Scientists are still exploring the slow distant role white dwarfs play within the broader structure of the galaxy, contributing faint gravitational influence to nearby objects, occasionally interacting with companion stars in ways that produce some of the most dramatic events astronomers observe, even from something that has otherwise gone almost entirely silent. What we understand so far suggests endings, even stellar ones, stretched out across spans of time too large to comprehend rarely mean total absence. They tend instead to mean a slow shift into something quieter, something that continues existing without needing to announce itself, without needing to shine, without needing to be noticed at all in order to remain real. The mind, it seems, has been keeping something still and patient all along, somewhere beneath ordinary waking thought, something that understands rest not as an ending, but as its own complete and necessary state. Perhaps that quiet understanding is not so different from what a star eventually settles into, either once its long bright chapter has finally gently run its course. And what that settling might actually feel like, if it could be felt at all, has less to do with stars or distant time, and more to do with something far closer already moving quietly through the body, right here in this room tonight. Something closer is exactly the right way to put it, because while all of this cosmic unfolding continues at its own unhurried pace, far beyond any single lifetime, the body lying here tonight is moving through its own quiet rhythm right now, one shaped in its own way by the very same star this entire story has been following. Scientists suggest that almost every living thing on Earth carries some form of internal rhythm tied to roughly 24 hours, a pattern so deeply embedded that it persists even in creatures kept in complete darkness with no access to sunlight at all. Researchers studying simple organisms, even single-celled cyanobacteria drifting in ancient oceans, have found rhythmic patterns of activity that rise and fall on a cycle close to a day's length, suggesting this kind of internal timekeeping reaches back further into the history of life than almost anything else that has been studied. Long before there were eyes to see light or brains to interpret it, something within living cells had already learned to keep time by it. That inheritance carries forward quietly into the body resting here now. Beneath conscious awareness, a complex orchestra of internal signals has likely already been shifting for the past hour or so, preparing for the kind of rest that follows naturally once daylight fades. Heart rate studies indicate tends to slow gradually in the evening hours, decreasing by a noticeable margin compared to its daytime pace, settling into a steadier, more even rhythm as the body eases out of alertness. Breathing follows a similar pattern, though it tends to receive far less attention. During wakefulness, breath often moves quickly, shallow, sometimes uneven, shaped by whatever thought or task happens to be occupying the mind in that moment. As the body relaxes, breathing tends to lengthen on its own, without any deliberate effort, deepening slightly, slowing in a way that mirrors almost exactly the kind of breath associated with calm. Researchers studying respiration during the transition into sleep have found that breath rate can drop by several breaths per minute, In this window alone, the body adjusting itself quietly, the way an instrument settles, once tuned with no further input required from the mind observing it. It seems that very little of this transition requires conscious participation at all. The body appears to already know precisely what to do, the same way it has known in some form for an extraordinarily long stretch of evolutionary time. What we understand so far suggests this kind of internal coordination predates conscious thought by a wide margin, embedded instead in older, more fundamental structures of the nervous system, ones shared in modified form with countless other species that also rest, also wake, also move through their own version of this same daily rhythm. Body temperature too follows its own gentle decline as evening deepens. Core temperature, which sits at its highest point somewhere in the late afternoon for most people, begins a slow, steady drop as night progresses, often falling by close to a full degree, before reaching its lowest point sometime in the deepest hours of early morning sleep. This drop is not incidental. Evidence suggests it plays an active role in making sleep itself possible, since the body appears to find it considerably easier to fall and stay asleep, while its internal temperature is already trending downward rather than holding steady or rising. There is something quietly poetic in that detail, a body that cools slightly in order to rest more deeply, almost as though warmth itself needs occasionally to step back just slightly to make room for stillness. The same warmth discussed earlier, carried originally from sunlight, absorbed gradually across the day, now eases downward in the evening, allowing the body to settle the way a room settles once a fire has been allowed to burn low. Sleep itself, once it begins, is far from the simple uniform state it might appear to be from the outside. Neuroscientists have observed that the brain moves through a series of distinct stages across the course of a night, cycling repeatedly through them in patterns lasting roughly 90 minutes each. The earliest stage involves a light, easily disturbed kind of sleep brainwaves, slowing only modestly from their waking pattern. From there, the body typically moves into deeper stages where brain waves shift into long, slow waves, a pattern researchers refer to as slow-wave sleep, associated closely with physical restoration, tissue repair, and the release of growth hormone even in adults long past the years, typically associated with physical growth. It may be that this deep stage represents something close to the body's most fundamental form of maintenance, a quiet internal housekeeping that happens almost exclusively during these specific hours, largely inaccessible during ordinary waking life. Studies indicate that immune function, cellular repair, and a wide range of restorative processes rely heavily on reaching this particular stage consistently, night after night, in a rhythm that once again traces back to that same ancient sun-linked clock. Later in the cycle, the brain shifts again, this time into a stage known as rapid eye movement sleep, or what researchers more commonly refer to simply by its descriptive abbreviation, drawn from the movement itself, the eyes shifting rapidly beneath closed lids, while the rest of the body remains almost entirely still, held in place by a kind of temporary protective paralysis. This is the stage most closely associated with vivid dreaming brain activity, in this period resembling in certain ways patterns seen during wakefulness, even though the body itself remains deeply motionlessly at rest. The brain tends to interpret this combination, an active dreaming mind paired with a still immobile body, as something almost contradictory, and in a sense it is. Researchers studying this paralysis have found it serves a clear protective function, preventing the body from physically acting out whatever unfolds within a dream. A quiet safeguard built into the architecture of rest itself, allowing the mind to wander freely while the body remains undisturbed, anchored safely in place. Across a full night, these stages repeat several times: light sleep, deep sleep, dreaming sleep cycling in a pattern that shifts slightly with each repetition, deep sleep tending to dominate earlier cycles, dreaming sleep gradually taking up more time as the night progresses toward morning. It seems that the body left undisturbed naturally distributes its different forms of rest across the night in a careful balanced sequence, one shaped by needs that shift gradually as sleep deepens and then eventually begins preparing for its own end. Much of this entire process distant as it might feel from anything discussed earlier about stars and fusion, and slow stellar fading traces back to that same small cluster of cells near the base of the brain still quietly timing everything, according to light and dark even now, even as that timing influences something as intricate as the layered architecture of a single night's sleep. The sun, despite playing no direct role in any of these internal mechanisms, remains in a sense the conductor standing somewhere just off stage, having set the tempo for this entire performance many hundreds of thousands of years ago. Psychologists often note that disruptions to this rhythm, irregular sleep schedules, prolonged exposure to artificial light late into the evening, tend to produce measurable effects on mood memory and overall well-being, suggesting just how deeply this ancient rhythm remains woven into present-day experience, despite how far removed modern life has become from the natural cycles that originally shaped it. The body in many ways still expects the same gentle handoff between light and dark that it has expected for an almost unimaginable span of time, regardless of how many additional hours of artificial brightness now surround it. There is something worth sitting with in that gently without turning it into any kind of correction or concern. Simply an observation. A body here tonight still quietly following a rhythm inherited from an enormous stretch of evolutionary history, still responding to darkness, the way it always has, still easing toward rest. According to a timetable set in motion, long before clocks, calendars, or any other measure of time existed to track it, memory too appears to depend closely on this nightly rhythm. Researchers have found that sleep plays an active role in consolidating memories formed during the day, sorting through recent experience, strengthening certain connections while allowing others to fade in a process that seems to unfold primarily during these specific deeper stages of rest. What we understand so far suggests the brain is in a very real sense still working while the body sleeps quietly, reorganizing, filing, refining even as conscious awareness drifts somewhere else entirely. It seems fitting in a way that a story spent so long tracing the sun's own long, slow internal processes, fusion shifting gradually from core to shell material, slowly settling and rearranging across billions of years, should arrive eventually at a body doing something quietly similar on a vastly smaller scale every single night. Sorting, settling, allowing certain things to strengthen and certain things to gently fade, all without requiring any conscious direction at all. Heart rate variability. A subtler measure researchers use to assess how smoothly the nervous system shifts between states of activity and rest tends to improve markedly during deep sleep, reflecting a kind of internal flexibility. A body capable of moving fluidly between effort and ease, much the way breath lengthens and shortens naturally throughout a quiet evening. Evidence suggests this flexibility plays a meaningful role in long-term health. The body's capacity to ease into rest as readily as it rises into activity, mirroring, in its own small way, the very balance discussed earlier between gravity and pressure expansion, and contraction, holding a star together across billions of years. It may be that very little of this needs to be understood in detail in order to be felt. The body, after all, has been managing this entire intricate process without any conscious assistance for as long as bodies have existed at all. There is no need to direct breath consciously towards slowness, no need to instruct the heart to ease its pace, No need to guide the mind deliberately through each stage of sleep in the correct order. All of it happens quietly, reliably, the way it always has, the way it likely will again tonight, whether or not any of it is noticed at all. What remains then is simply permission, a kind of quiet trust extended toward a system that has clearly been doing this work faithfully for a very long time, already, long before tonight, long before any single life currently living happened to begin, and it may be worth considering gently before drifting any further, just how much of what feels personal, this particular rhythm, this particular night, this particular slow easing toward rest, is actually something shared, something carried in some form by nearly everything that has ever lived beneath this same quiet, ordinary, endlessly patient star. Something shared, in fact, runs far deeper than rhythm alone. It reaches back further than birth, further than evolution, further even than Earth itself, into the very atoms that happen to make up a human body resting here tonight. Scientists suggest the universe in its very earliest moments contained almost nothing in the way of variety. The Big Bang produced overwhelmingly just two simple elements, hydrogen and helium, along with the faintest trace of lithium scattered outward into a young, expanding cosmos with almost no structure at all. Nothing heavier existed yet. No carbon, no oxygen, no calcium, no iron, none of the elements that would eventually become necessary for anything resembling life. For a long stretch of cosmic time, the universe was in a very real sense almost entirely without ingredients. Everything heavier than that simple beginning researchers have found was forged later inside the cores of stars. The same nuclear fusion responsible for the sun's light hydrogen, converting into helium, eventually fusing into carbon and oxygen, represents only the earlier chapters of a much longer process that more massive stars carry considerably further. Inside stars far larger than the Sun, fusion continues building heavier elements. Still carbon into neon into oxygen. Oxygen eventually into silicon layer by layer, each new element requiring greater heat and pressure than the one before it, until the process reaches iron sitting near the very center of the most massive stars in their final active stage. It seems that iron marks something of a quiet limit. Fusing elements lighter than iron releases energy, the same kind of energy that has powered every star discussed throughout this story so far. But fusing iron into anything heavier requires energy rather than releasing it, and a star, however massive, eventually runs out of any way to sustain that kind of cost. When a sufficiently massive star reaches this point, its core can no longer hold itself up against its own gravity, and it collapses almost instantaneously in an event far more violent than anything the Sun itself will ever experience. The outer layers no longer supported rebound outward in a tremendous explosion. Astronomers call it a supernova. Studies indicate that within the extraordinary heat and pressure of a supernova, in just a matter of seconds, elements heavier than iron are finally created, scattered outward, along with everything the star had already built across its lifetime. Golden trace amounts may form this way. So might portions of the silver, the platinum, and countless other heavier elements that exist in only small quantities throughout the universe. A single explosive moment briefly outshining an entire galaxy, responsible for scattering material that no ordinary star could ever produce on its own. It may be that thinking of an explosion as something generous feels strange at first. Explosions in most contexts suggest only destruction. But scattered amid all the violence is also distribution material that had been locked away inside a single star's core, suddenly released outward into space, drifting through the galaxy, eventually settling into the vast, slow clouds of gas and dust from which new stars and new planets would later form. evidence gathered more recently drawn from an entirely different kind of cosmic event, has added another layer to this story. In the year 2017, astronomers detected gravitational waves, tiny ripples in the fabric of space itself, originating from two neutron stars colliding the dense collapsed remnants of stars, even more massive than those that produce ordinary supernova. Telescopes around the world turned toward the source almost immediately, capturing light from the aftermath light that revealed the formation of substantial amounts of gold and other extremely heavy elements created in the brief violent merger of two objects, each smaller than a city, yet denser than almost anything else known to exist. What we understand so far suggests much of the gold, the silver, the heaviest elements found scattered throughout the universe, may trace their origin, not only to supernovae, but to collisions like this one, to ancient stellar remnants, finally meeting after spiraling slowly toward one another across an almost unimaginable span of time, releasing in their final moment together enough material to help build eventually distant worlds neither one could ever have imagined existing. There is something quietly moving in that ending and a beginning occurring in the very same instant, inseparable from one another. The same collision that destroyed two ancient remnants also scattered the raw material for whatever might form afterward, somewhere else sometime later, far beyond the reach of that original light. The cloud of gas and dust that eventually became the sun and the solar system scientists suggest was not simply pure hydrogen and helium left over from the early universe. It had already been enriched gradually by generations of stars that lived and died long before the sun ever began to form. Each supernova, each neutron star collision, each slow release of material from an aging giant added a little more variety to the surrounding cloud, a little more carbon, a little more oxygen, a little more iron and calcium and nitrogen scattered outward and mixed slowly into the vast clouds drifting through that region of the galaxy. By the time gravity finally pulled enough of that enriched cloud together to ignite the sun, the surrounding material, the same material that would eventually form Earth and oceans, and eventually much later every living thing those oceans would come to support already carried within it the scattered remains of countless earlier stars. Stars that burned and changed, and eventually ended long before the sun's own story even began. It seems that the calcium-forming bone quietly holding the shape of a body resting here tonight did not originate on Earth at all. It was built originally inside the core of some ancient massive star released outward in its final explosive moment, drifting through space for an unknown stretch of time, before finally settling into the cloud that became this solar system. The iron carried within blood responsible for moving oxygen quietly through the body, with every breath traces back the very same way, forged inside a star that no longer exists in an event that occurred long before Earth, long before the sun, long before anything resembling a recognizable shape of this present moment. Neuroscientists have observed that contemplating connections of this kind, deep factual, almost startlingly literal connections between the body and the wider universe, tends to activate something researchers describe as a sense of cosmic connectedness, a feeling distinct from ordinary curiosity closer in nature to belonging. Studies indicate this particular sense of connection correlates fairly consistently with lower reported stress and with a quieter, steadier kind of contentment, the sort that does not depend on circumstances changing, but rather on perspective gently widening. It may be that this sense of belonging makes a certain kind of intuitive sense once held up against the facts themselves. The boundary between a living body and the universe surrounding it becomes considerably less distinct upon closer examination. The same elements found scattered across distant nebulae glowing softly in telescope images taken from observatories around the world are the very same elements quietly arranged into bone, blood, breath thought. Psychologists often note that feelings of separateness, the sense of being a single, isolated thing moving through an indifferent universe, tend to ease somewhat when this kind of factual connection is genuinely understood rather than simply repeated as a pleasant phrase. It is not metaphor exactly, though it carries metaphorical weight. It is closer to a literal traceable lineage atoms that existed inside ancient stars, surviving intact through explosion dispersal, gradual gathering into new material, eventual incorporation into a forming planet, and finally, after an extraordinarily long and patient journey, into a living, breathing, currently very tired body, lying quietly in the dark. The sun itself, in this sense, occupies an unusual position within its own story, both ancestor and descendant at once. It formed from material scattered by stars that came before it, the very same kind of process that will eventually scatter its own material outward for whatever forms after it. Its core today is fusing hydrogen first created in the earliest moments of the universe, while the carbon and oxygen it will leave behind once its own life concludes will eventually rejoin the same great slow cycle, settling somewhere new, perhaps becoming part of an entirely different star, an entirely different planet, an entirely different living thing far in some distant, currently unimaginable future. There is a kind of quiet continuity in that worth resting on for a while. Nothing across this entire story so far has truly been described as ending in any final absolute sense. Hydrogen becomes helium, helium becomes carbon and oxygen, a star's outer layers become a nebula becomes the raw material for a new generation of stars and planets. And scattered somewhere within that vast continuous unfolding sits a single particular arrangement of atoms, briefly organized into the shape of a person lying quietly in a dark room, very far from any star, yet built in every measurable sense from the same material those stars have been patiently producing and releasing for billions of years. What we understand so far suggests this is simply how matter moves through the universe, gathering, transforming, dispersing, gathering again with no real beginning and no real end, only a long, slow continuity that occasionally briefly takes the shape of something capable of lying still at the end of a long day, breathing slowly, quietly aware for a little while of being part of something this vast. It may be that very little needs to be done with a thought like that beyond simply letting it rest here for a moment, the way starlight settles quietly onto a dark field without asking anything of the ground it lands on. A body built from old starlight resting now beneath new starlight, neither one needing to understand the other completely in order to belong quietly to the very same unfolding story. And there is perhaps one last quiet thread left to follow, not forward into deep cosmic time, but simply downward into stillness itself, into whatever waits gently on the other side of everything this story has carried so far. The other side of everything this story has carried so far begins somewhere very closer than any star, closer even than this room. It begins in the quiet space between being awake and not being awake at all, a threshold the body crosses almost every night, usually without ever noticing the exact moment it happens. Neuroscientists have observed that the brain does not simply switch off when sleep begins. It shifts gradually through a soft transitional state researchers call hypnagogia, the brief blurred territory where waking thought starts to loosen its hold, but full sleep has not quite arrived either. Brainwaves recorded during this window show a slow drift away from the quicker, more alert patterns of wakefulness towards something slower, heavier, less defined at the edges. Thoughts in this state often stop behaving the way they do during the day. They drift sideways. They blur into images rather than words. A sentence might begin clearly and end somewhere unexpected, the mind no longer holding tightly to its usual structure. It seems that this loosening is not a malfunction of any kind, it is closer to a release. Studies indicate the brain's tighter, more goal-directed processes ease their grip during this transition, allowing looser, more associative patterns of thought to surface. Instead, fragments of memory, faint images, sensations with no clear source. This is in a sense the mind beginning to set down its sharper tools for the night. Researchers have found that the body too settles into this threshold in its own way. Muscles soften further than they have all day. The eyelids already closed grow heavier still, even with nothing left to hold open. Breathing continues its gentle lengthening, each inhale arriving a little slower than the one before it. There is something gentle in knowing this is simply what bodies have always done long before anyone had a word for it. The mind, in these final stretches before true sleep, often loses track of time in small, harmless ways. A few minutes can feel like much longer. A single drifting thought can feel as though it lasted an entire conversation. The brain tends to interpret the passage of time differently once the more active clock-tracking parts of waking thought begin to quiet down, a softening that makes the night feel less measured, less divided into minutes, and more like one long, continuous stretch of stillness. It may be that this is part of why night itself has always felt to so many people across so much of history like a separate kind of time altogether. Not lesser, just different. Slower in a way that daylight rarely allows. Somewhere in this same quiet window, the boundary of the self also tends to soften. What we understand so far suggests the brain's sense of being a single, located, continuous person depends heavily on certain networks that stay especially active during focused wakefulness. As those networks ease, the felt sense of being someone somewhere doing something tends to loosen along with them. This is perhaps part of why falling asleep can feel less like a decision and more like a kind of gentle dissolving, the edges of awareness growing less distinct the way a coastline grows less distinct in fog. None of this requires effort. None of this requires understanding either. The body has been doing this faithfully every single night for as long as there have been bodies capable of resting at all. Outside, somewhere on the other side of the world right now, the sun continues exactly as it has for 4.5 billion years. Still warm, still steady, still many billions of years from any of the slow changes traced throughout this story. Tonight asks nothing of that distant fire. Tonight only asks for rest. The light is already low now. The thoughts are already slower. There is nothing left to explain. Only the soft weight of the blanket. Only the quiet rise and fall of breath a little longer now than before. Only the dim, fading edges of a room that no longer needs to be seen clearly to feel safe. Somewhere far off, a star continues burning, patient and unhurried the way it always has. And somewhere closer, much closer, everything is finally allowed to go still. Just this quiet. Just this dark. Just this slow, soft drifting gentler now than words fading the way a single point of light fades into a clear dark sky, until there is nothing left to follow but rest.